day to you all. We are still on to probability of dependent and independent events. Right away, we are going to look at an example on independent events. We still have outcome tables and probability tree diagram to look at. But very quickly, let's take a look at this example that says the probability that 3 boys will pass an examination are 2 over 3, 5 over 8, and 3 over 4, respectively. Find the probability that all the 3 boys pass, none of the boys pass, only 2 of the boys pass. Now we'll take one after the other. Probability that all the 3 boys pass means that the first boy passes, the second boy passes, and the third boy passes. I have decided to use P to represent my pass and F to represent fail. So for each of the boys, I'm going to use P for pass and F for fail. Probability that all 3 boys passes or pass, that will be probability that we have the first boy as P, second boy as P, and the third boy as P. Now, the first boy passing, that's 2 over 3, second boy passing, that's 5 over 8, and third boy passing, that's 3 over 4. Remember, this is multiplication because I've just read it as first boy passes and second boy passes and third boy passes. So the and makes use of the multiplication law of probability. So simplifying that, that gives me 5 over 16. Now let's take a look at the second part of the problem that says we should find probability that none of the boy pass. None of the boy pass means the first boy fails, second boy fails, and the third boy fails. Probability that the first boy passes is 2 over 3. Probability that that first boy fails will be 1 minus 2 over 3. In other words, that's going to be 1 minus probability that it passes. Remember, we have talked about probability of something happening as 1 minus probability of the thing not happening. So we have 1 over 3. How did I get my 1 over 3 in such simple way without working out LCM? That's going to be just the denominator of this 3 minus the numerator, which is 2. So 3 minus 2, that gives me 1. So that's how I got my 1, and it becomes 1 over 3. Now the second boy passing, we have 5 over 8. His failing will become 8 minus 5. That will be 3 over 8. The third boy passing, that's 3 over 4. Then his failing will be 4 minus 3. That's 1 over 4. So that gives me the probability of each of the boy failing. So what I need to do is to work out the probability of the first boy failing, second boy failing, third boy failing as PFFF. Now that gives me 1 over 3 times 3 over 8 times 1 over 4. That's 3 over 96, and that simplifies to 1 over 32. So that makes very easy the solution to B. Now the solution to C. This one is the main question. Now the problem says we should find probability that only 2 of the boys pass. If only 2 of the boys pass, it means that we have the first boy passing, second boy passing, and third boy failing as a possibility. We also have the possibility of the first boy passing, second boy failing, and third boy passing. That is a possibility. Or we have the possibility of the first boy failing, the second boy passing, and the third boy passing. That is another possibility. So it's either PPF or FPP, PFP or FPP. So it's going to be any of these 3. So the OR will make us to add the various probability for each of these. Now we take them one after the other. Probability that the first boy pass, second boy pass, and third boy fails. I've written the part of the question that we need to look at in a calculation here. So first boy passing, that's 2 over 3. Second boy passing, that's 5 over 8. And the third boy failing. Now it's not going to be 3 over 4. That will be 4 minus 3, that's 1. That's 1 over 4. So that gives me this calculation here, and then simplifies to 10 over 96. I'm not going to simplify this. I'm not going to reduce to the lowest term because I'm still going to make use of this in the final answer to make my working easier at the end of the day. Now let's check the next one. That's probability of the first boy passing, second boy failing, and the third boy passing. So that gives me 2 over 3 for the first boy, that's 2 over 3 for his passing. Then for the second boy failing, his passing is 5 over 8, then his failing will be 8 minus 5, that's 3 over 8. Then the third boy, his passing is right there, 3 over 4. So I put 3 over 4 right here, and then simplifying that gives me 18 over 96. I'm still not going to simplify. I remember I said that this will help me out in my final calculation. So let's take the last one, probability of the first boy failing, second boy passing, and the third boy passing. Now, first boy passing, remember, is given to us as 2 over 3. His failing will be 3 minus 2, that's 1 over 3. So the second boy passing, that's 5 over 8. The third boy passing, that's 3 over 4. Multiplying all three together, that gives me 15 over 96. 15 over 96 is the answer to the third one. So eventually we have to work out three of them together. The first one, PPF, that's 10 over 96. Sorry, this is not supposed to be PPF, this is supposed to be PFP. So the second one, PFP, that's 18 over 96. And the third one, FPP, that's 15 over 96. So summing all these together, why? Because probably that only two of the boys pass means PPF or PFP or P or FPP. So any of these means that only two of the boys pass. So the addition sign will be used in place of the or, and then we have all three sums added together. That gives me for 3 over 96. That is my final result. For 3 and 96 cannot be simplified further than this. So you see why I left all denominators, all the calculations earlier not being simplified, because I knew that my denominator as 96 for each of them will help out in simplifying quicker instead of trying to look for LCM for the three denominators. So that settles it for this particular problem. We still have outcome tables and probability tree diagram to look at. After this class, we will attempt to look at that when we meet again.